common question arises concerning the amperage rating of Leviton's 20 amp switches, specifically whether their maximum amperage is actually 16 amps. This is not accurate. Leviton's 20 amp switches are designed and rated to handle a maximum amperage of 20 amps. Understanding the amperage rating of electrical components is critical for safe and compliant electrical installations. Using components beyond their rated capacity can lead to overheating, damage to the equipment, and potentially hazardous situations. The stated amperage on a switch or any electrical device represents the maximum continuous current it can safely handle under normal operating conditions. When selecting switches and other electrical devices, it's crucial to ensure they are appropriately rated for the intended circuit. Overcurrent protection devices, such as circuit breakers or fuses, should be sized to protect the wiring and the connected devices. The National Electrical Code, or NEC, provides guidelines for determining the appropriate size of conductors and overcurrent protection for various applications. The NEC Table 310.15b16 provides ampacity ratings for conductors based on their insulation type and temperature rating. The ampacity of the conductor should be equal to or greater than the rating of the overcurrent protection device. The overcurrent protection device should be sized no larger than the ampacity of the conductor it is protecting. This ensures that the wiring is protected from overloads and short circuits. For example, a 20 amp circuit typically requires 12 American wire gauge, or AUG, copper conductors with a 75 degrees Celsius insulation rating and a 20 amp circuit breaker. It is also important to consider voltage drop in conductors. Voltage drop occurs when the voltage at the load is less than the voltage at the source. Excessive voltage drop can cause equipment to malfunction or operate inefficiently. The NEC provides guidelines for calculating voltage drop. Voltage drop should be limited to 3% for branch circuits and 5% for feeders. When selecting switches for lighting circuits, it is important to consider the inrush current of the lamps. Inrush current is the high initial current that flows when a lamp is first turned on. Some types of lamps, such as fluorescent lamps and LED lamps, have high inrush currents. Switches used with these types of lamps should be rated for the inrush current. Electronic switches may be required for some LED lighting applications. In addition to amperage and voltage ratings, switches are also rated for horsepower. Horsepower rating indicates the maximum horsepower of a motor that the switch can control. When selecting switches for motor circuits, it is important to ensure that the switch is rated for the horsepower of the motor. Some switches are also rated for specific types of loads, such as inductive loads or resistive loads. Inductive loads, such as motors and transformers, can generate voltage surges when switched off. Switches used with inductive loads should be rated for these voltage surges. When installing switches, it is important to follow all applicable electrical codes and safety regulations. All wiring connections should be made securely and properly insulated. The switch should be mounted in a suitable enclosure. It is also important to label the switch to indicate the circuit it controls. Regular inspection and maintenance of electrical switches can help to ensure their safe and reliable operation. Switches should be checked for loose connections, damaged insulation, and other signs of wear and tear. Any damaged or worn switches should be replaced immediately. If you are not qualified to perform electrical work, it is important to hire a licensed electrician. Working with electricity can be dangerous, and it is important to take all necessary precautions to avoid electrical shock. A crucial aspect often overlooked is the dirtying of electrical components under certain conditions. For instance, if a switch is installed in an environment with high ambient temperatures, its current carrying capacity might be reduced. The manufacturer's specifications will outline any necessary dirtying factors. Another factor is the type of load the switch is controlling. Resistive loads, such as incandescent lights, draw a relatively constant current. Inductive loads, like motors and transformers, can draw significantly higher inrush currents when they are initially energized. Switches must be able to handle these inrush currents without being damaged. Solid-state switches, which use electronic components instead of mechanical contacts, are becoming increasingly common. Solid-state switches offer several advantages, including longer life, faster switching speeds, and reduced arcing. However, they also have some limitations, such as higher cost and sensitivity to voltage surges. When selecting a switch, it is important to consider the specific application and the advantages and disadvantages of different types of switches. The NEC specifies requirements for the installation and wiring of switches. These requirements are intended to ensure the safety of electrical installations and prevent electrical hazards. The NEC section 404.2 covers the requirements for the location of switches. Switches must be readily accessible and located so that they can be operated safely. The NEC section 404.14 covers the requirements for the rating of switches. Switches must be rated for the voltage and current of the circuit they control. It is important to always consult the latest edition of the NEC for the most up-to-date requirements. Many different types of switches are available, each designed for a specific purpose. Single-pole switches are the most common type of switch. They are used to control a single circuit from a single location. Double-pole switches are used to control two circuits from a single location. Three-way switches are used to control a single circuit from two locations. Four-way switches are used in conjunction with three-way switches to control a single circuit from three or more locations. Dimmer switches are used to adjust the brightness of lights. Timer switches are used to automatically turn lights on and off at preset times. Occupancy sensors are used to automatically turn lights on when someone enters a room. Understanding the different types of switches and their applications is essential for selecting the correct switch for a particular job. Proper wiring techniques are essential for ensuring the safe and reliable operation of switches. All wiring connections must be made securely and insulated properly. The correct wire size must be used for the circuit. The grounding conductor must be properly connected. It is important to follow all applicable electrical codes and safety regulations when wiring switches. Regular maintenance of switches can help to prevent problems and extend their lifespan. Switches should be inspected periodically for loose connections, damaged insulation, and other signs of wear and tear. Any damaged or worn switches should be replaced immediately. Lubricating the moving parts of a switch can help to keep it operating smoothly. If you are not qualified to perform electrical work, it is important to hire a licensed electrician. Working with electricity can be dangerous, and it is important to take all necessary precautions to avoid electrical shock. In summary, the Leviton 20 amp switch is designed to handle 20 amps, and it is critical to understand the electrical ratings, codes, and best practices for safe electrical installations.